wild interacts with the elements of its environment in a way we can never see in captivity. As we grow to appreciate how perfectly adapted the creature is to its natural habitat, we learn of the forces that shape, alter, or destroy this balance. Hello, my name is Betty White, and my lifetime passion is animals. All animals. Sea otters in particular. As we have developed an understanding of and a sensitivity to the health of our planet, we've been able to change destructive habits and to bring species back from the brink of extinction. The saga of the southern sea otter was one of the most touching of these success stories. The story begins in the 18th century when fur traders from all over the world journeyed to the west coast of North America seeking the sea otter pelts, which were prized as the most luxurious fur in the world. In the next 100 years, the fur traders slaughtered nearly 200,000 sea otters in California and in Baja California, Mexico. Public outrage prompted efforts to save the otters, but the gesture came too late. By the time the International Fur Seal Treaty was passed in 1911, the southern sea otter was thought to be extinct. Then, in the 1930s, a small miracle happened. Scientists discovered a tiny colony of between 30 and 50 southern sea otters hidden off the rugged coast of Big Sur, California. Gradually, the sea otter population increased until in the mid-1990s, approximately 2,400 otters populated the central California coast. The otters were isolated to a small portion of their original range, which once extended as far south as Baja California. Because the otters play and forage close to shore, they're easily spotted from land.
Just about a year or two ago, a big problem surfaced in an inland body of water called Pinto Lake. And with sea otters being the sentinel species of the ocean, where what they're dealing with is a wake-up call for humans, for other animals. And what we saw in Pinto Lake was a toxin, microcystin, that's a freshwater blue-green algae that's affecting sea otters in a dramatic way. I think there was something like 21 or so sea otters that were killed by this blue-green algae, and it's certainly not a new phenomenon with this microcystin. We've seen it in other places in California, we've seen it worldwide.
My job is to examine the otters that are found dead along the coast and translate what's found in those animals to back to the living population to see what we can do to benefit living sea otters. And one of the things that is scary in my line of work is when you see something that is new or that you haven't noticed before. And that's exactly what happened in 2007 is as I was examining some sea otters, what I was noticing is that these otters were bright yellow. And what I mean is their gums were yellow, the whites of their eyes, instead of being white, were yellow. Internally, they were yellow. And this isn't something that I had noticed before. And it wasn't just one otter, it was multiple otters. And so I became concerned about this, that this was some kind of new disease process, or certainly newly recognized. And as part of this examination, we were trying to determine what the problem was, where the source of this problem was, and what we could do to fix that. In the process of doing these post-mortem examinations, what you'd call in the human world an autopsy, but in the veterinary world we call it a necropsy, what we found was evidence of very severe liver disease. Going down through the list, I was left with something that made sense in terms of what I was seeing in the animals, but not in terms of what I learned in veterinary school. And that was a group of toxins that I had understood were associated with freshwater and not the ocean system. And I called a friend who worked with the Department of Public Health and asked him if he thought I was crazy to consider this as a differential. And he said, "You're going to laugh when I tell you I stepped out of a meeting on this exact topic to take your call. And so no, I don't think that you're crazy, and I think you should try testing for that." So we did, and we found a laboratory luckily in state and within our own department that was able to do this test with high precision. And they were able to confirm, sure enough, it's this group of toxins called microcystins. And that these otters were getting exposed to something that, based on everything I could see, had never been reported in a marine mammal before. Once we were able to confirm that we had not one, but several, and in fact, in just the year of 2007, we had 12 confirmed cases in sea otters of microcystin poisoning causing the death of sea otters, a marine mammal. That really led us to saying, okay, where are these animals coming across this toxin? Because from everything that we were able to see in the literature, this is really more of a freshwater issue. I phoned a friend, an expert on water systems within the central California coast. Her name was Karen Worcester, and I asked her about any local rivers, lakes, streams, that sort of thing that might have had previous reports of this toxin. And she said, something's ringing a bell about this. Let me think about it and I'll get back to you. And I had said to her that the majority of our cases were being found in the Monterey Bay area, so kind of focus your thinking in that area. She called me back and she said, I figured it out, it's a lake called Pinto Lake.
I've been working with Melissa Miller on sea otter issues for a number of years now, maybe even a decade. We started working on pathogenic diseases entering the ocean, and more recently Melissa's uncovered this problem with blue-green algae, which appear to be creating toxins that are entering the food chain and then are getting into sea otters. It's a really compelling issue for me because it's about the land-sea interface and how things we do on the land enter our creeks and streams and flow into the ocean, enter mollusks and other animals sea otters might be eating and then are taken up by sea otters.
We had a pretty clear connection that toxins are present in the coastal environments. They're linked to the ocean, in that case from Pinto Lake into Corralitos Creek. Corralitos Creek dumps into the Pajaro River. The Pajaro River obviously dumps straight into Monterey Bay. And so we had the smoking gun, but we didn't really have the evidence that you could actually get the toxin out of the water and into the otter.